starting to see some more signal back across the across Texas and across the Gulf Coast. So again, okay, so this is 6 events making, again, this is made up of an average. So we can look at, let's look at the, this is the El Nino of 94, 95, a moderate El Nino. So, oh, I'm sorry, let's go forward. Okay. Much above normal over most of California. So, I mean, we're talking 8 to 10 inches above normal. And this is capped at 10. Some of those areas may be 12 or 15 inches above normal. So, about the same. Texas, Gulf Coast is sort of a mixed signal. So certainly very different than what is typical. So if you've been expecting a typical moderate event this year, you would have been in trouble. This is also a moderate El Nino. See how we can get in trouble? So this was from 1976-77. Okay, all the people here with gray hair, why is 76-77 significant? That was our last big drought before the current drought. And actually the reservoir levels were lower in the major reservoirs in the state than they are right now. So you average these two together, and this is what you get. So there's a cautionary tale about averaging El Nino events together. Looking at strong events, again, all along the coast is on the order of 4 inches above normal, and a couple inches above normal on the inland areas. Only 3 events in this category. Now here's why. Let's look at two separate strong events also. So this was 72, 73, nice and wet here. Again, looking at that dry signal in the Pacific Northwest as the polar jet drops around on into the New England area, and much wetter than normal across the mid-plains, southeast, and on into the Atlantic coast. But we can also look at a strong event 65-66. Is that? Yeah, 65-66. Also a strong El Nino, and very, very dry. Now this is the outlier in the strong category. The other 2 strong events were well above normal. If we look at the 2 very strong events, so again, that's our 82-83, 97-98, huge wet signal, even extending up into the Pacific Northwest. So we're in the very strong category now. So this is what we're hoping for. But remember, we're looking at 65 years of data in total. This is, but a sample size with these very strong events of 2. So and there's some precautionary, sorts of tales that we really have to, scenarios that we have to consider. This is where we are relative to 97 and 98. So we are right on track. These are looking at the monthly 3.4 region anomalies. So the blue one is 97, 98. Gets to about the first of the year, it drops off. The progged values that we'll be looking at stay right along this curve as we go on into the rest of the winter. So that is certainly encouraging if we're looking at this as a model for what we want. This is a comparison with the sea height anomalies this year on the right, 97, 98 on the left. The signature looking very much the same as we go on in. Anybody notice a difference on this though?
My warm pool up in
the warm pool up in the
Pacific Northwest.
In the Pacific Northwest was not really as, okay, let's go back through here. It's slightly above normal. The greens are a little bit above normal, but some near normal in here. Certainly not like the anomalies that we are seeing over here. That is really, that's the warm blob associated with the ridiculously resilient ridge. I hate that term. whether, whether the warm water is a byproduct of that, the ridge is a byproduct of the warm water, or there's a lot of feedback and coupling going on, which is probably the most likely scenario. We certainly didn't see that in 97, 98. And we don't know what's going to happen. That if that stays up there, I mean, we may have this enhanced jet across the, across the southern part of the area. In which case, then maybe we're looking to see where is the above normal line. Is it the Golden Gate? Is it the Oregon border? Is it the Tehachapies? This is now, we're even going to come down, we've been looking at seasonal rainfall. This comes down now to looking at monthly rainfall. And I just put this together a couple weeks ago, and I'm really surprised that I found. So this is November, the average for the strong and the very strong events combined. I didn't want to bias it by just doing the two very strong events. I want to give it a little more breadth. So you have on the left-hand side is the strong events. On the right-hand side is the very strong events. So San Jose, the strong events, so that's 57, 58, 65, 66, and 72, 73, 190% of normal, 252% of normal for 82 and 90, 97. And you can see other places around the state, huge numbers down in Southern California, as we would sort of expect.
So we only have to wait a month to find out if this is...
We only have to wait a month to find out if the averages are going to work out. And that's going to be kind of interesting because, okay, is that going to, what's that going to do as far as confidence about what the El Nino is going to do? Is November, going to be representative? The big thing I found that really surprised me, and everybody else I've shared it with, here's December. December almost universally, especially for very strong events, was below normal. And if you start plotting out, do time series of each of the different cities here, areas across the state, you get this drop off in December, and then it comes back gangbusters here in January. Again, big numbers, 200% of normal in these areas. The Sierra Nevada indexes. This is probably the most important number in this chart because that's where most of the state's water comes from. From Shasta, this is the 8-station index. It's 8 precipitation stations north of the American River around to Mount Shasta. It's where Oroville, Shasta, Folsom, Siskiyou, all those big reservoirs. That's where they are. That's where we need the water. It could rain 500% of normal across Southern California, and there aren't many reservoirs to catch it down there. Hopefully it gets into the Colorado River Basin and they can draw some of it back out that way. But for rainfall, we need it to be certainly north of the Tehachapies, and best scenario is up here in the northeastern quadrant of the state. February, again, big numbers, almost 300% of normal on average around the Bay Area. There was on the order of, I think it was 26 or 27 rainy days in San Francisco this year, in February of 1998. Now people were getting grumpy at that time. Oh, well, it'll never stop raining. Not many people are being grumpy this year. They go, can we go for all 28 or 29? It's going to be a leap year. So we get an extra day to go on February. Still big numbers in March. And even April, but the April amounts are lower. And then if we look at the average, so we're now looking into the whole season. Strong events for San Francisco, 134, 128 for San Jose, 198, 202. About 2/3 above normal in the Northern Sierra. Now, we need to put this in the context of the rainfall deficits in the state. So we are down, we've had on average around the state about 3/4 of the normal rainfall for the last 4 years. So we're down those 3 1/4. So we're down those 4 1/4. So we're down a full rainfall season. So to make up the rainfall deficit, we not only have to get this year's normal rainfall, we have to get all of what we have missed for the rainfall deficit. Now, rainfall deficit does not equal drought. drought is really this big fuzzy picture. If you're raising cattle on Mount Hamilton, you get a normal rainfall season, all the grasses are going to grow, you're going to be in good shape. If you're a water manager for Santa Clara Valley Water District, you want to start recharging some of that groundwaters also and filling all the reservoirs. So you may need 150% of normal. If you are, trying to fill Shasta or Oroville, you're going to want 200% of normal. So, some of the numbers you'll see about the drought and the things like the drought monitor, you need to kind of put that in the perspective of who the user is. And one thing that the drought monitor doesn't, and I wish I had included a slide, I apologize, does not do, it really doesn't take into account that rain falls in the northeastern quadrant of the state, but it gets used in a lot of other parts of the state. So, if it can have an impact on what the drought really is, and whether how much we can get out of the drought, how much of that red we can get off that drought monitor map. Okay, here's the current sea surface temperature anomalies. And we sort of have looked at this. Nice time series though. The static picture. So we are this area of plus 2.5 here, and extending on out here, I guess plus 3.0 in the center. So the average in this area for the 3.4 region in this box in here is about 2.3, I believe, right now. So certainly getting into the warm category. Here's the anomalies for the last 4 weeks. This is the subsurface temperatures. So that all that warm water that we want to see that is under the surface has certainly, and this is from 0 down to 300 meters. So that's 900 feet or so, almost 1,000 feet. So a lot of warm water, a lot of energy, a lot of thermal expansion in that area. And we can see that those numbers are staying pretty static and warm, and that's really what we need to keep this event going. Here's over the last couple of months, and again this nice warm pool of water. Not a lot of shift of the western boundary. These are now the forecasts. So this is the infamous forecast plume. This is 22 different models, and they are all taking us up, sort of up around this the mean, which is this I believe the solid line here. I'm sorry, no, that's not the mean. It's this fuzz line here. It gets right up to about 2.5 for 2-3 month periods, and then it starts dropping off. Again, looking very much like 97, 98. So this is certainly, and the models have done actually a very good job this year. While last year they really over forecast the El Nino. If we look at the models that we're seeing in the plume we saw in April, it had it extending right up to about 2.0, and then in May and June, it gradually got a little bit stronger and stronger, and since July, it's had it peaking at 2.5, which is right where 97, 98 peaked at. This is the NOAA model extracted from that previous set, and what the sea surface temperatures are expected to be in these 3 months periods. So November, December, January, there's plume remaining on pretty solid through the February period, and then beginning to drop off as we get into March, and then the February, March, and April, it gradually is diminishing, and that's what we're seeing in the time series there. Scripps also does sea surface temperature forecasts. So this is the one for December, January, and February, and then April, May, and June showing things cooling back down toward normal, but still a cool pool lingering. But then this may be the most appropriate.